Hi everyone, welcome back to my channel. In today's video, we are diving into digital design by using AMD Xilinx Vivado to build basic logic gates. Let's start from scratch. First, you click on Create Project and you click Next to process project. And in a project name window, you have project name and project location. You can rename project in here and change the location in project location. And my location I locate in E storage. I click next. Now you can see the project type window. Here we must select RTL projects. And what's about RTLs? RTL stands for Register Transfer Level, which means we write our own hardware description codes like Verilog to define the circuits. And crucially, you must click on Do Not Specify Source at this time, because this tells Vivado to create a clean and empty project first. It gives us the flexibility to create and write our Verilog file later inside the workspace, rather than focusing on to import existing file right now. After that, just click on Next. In a default path window, where we choose our target FPGA chip. What's about FPGA? FPGA stands for Field Programmable Gate Arrays. It is an integrated circuit designed to be configured by a customer or a design after manufacturing. Let's look at hardware specs. I choose General Artist 7. You see, and this is very important in FPGA. At first, I'm going to show that I/O pins cost and available I/O pin. It's about available I/O pin is input/output block, while the chip has total pin counts. And with external hardware like less and switch is output. I/O pin count is total count can in FPGA, and it total have 236 pin. And second, I do show that LOT elements. LOT stands for lookup table, and this is very important for combinational logic. FPGA don't have permanent physical AND gates or NOT gates. Instead, they use the LOT to store truth table and stimulate gate behavior. And the third, flip-flop, and they are on-bit storage elements synchronized by a clock channel to build sequential circuits like register and state machine. And the final, I told you that DSP, and DSP stands for digital signal processors, and they are high-speed hardware multi-adder for complex mathematical and calculations. And after you select and you complete and go to the save file, and you select Next and finish. Now that our project is ready, let's create our first hardware design file. On the left panel, you see artwork, and you can use simple plus to artwork. First, I use artwork in the left panels. you click on add source, and you click on add or create design source. You click next. You click on create file, and this create file you can name your project, and I name for my project is logic gate. Your verilog and its location in this project one. You click OK. You finish. You skip this and click OK. Yes. And now you see in design source, you see logic gate. You click on logic gate, and this window you programmable verilog for logic gate in here. First I type program in here, input A, input A and B, output AND gate, OR gate, and NOT gate, and this AND or NOT is very basic gate in digital processing. You have command, enter, assign, AND gate equal A, B, At first, you can see modules, logic gates, and AND modules. This defines the boundary of our hardware block. It's like a black box or is a chip. Inside the brackets, we declare our ports, inputs A and B as the two inputs Y, and outputs AND gate, OR gate, and NOR gate as the outputs Y. Next, we have the assign statement. In verilog, assign represent a continuous assignment. It creates a permanent physical Y connection. We use the ampersand for the AND logic. Use the vertical bar for OR logic, and the title for NOT logic and AND module. You see in the right corner, if you see the green, and everything is okay, and you save your file. My code is written as saved. The next step is visual or circuits. You click on open elaborate design. Okay. And you look at the screen. Vivado has successfully translated our test code, actual get symbol, and get, or get, or and not get, and to schematics. Now that we have verified our RTL schematic, let's move on to the simulation phase to check if our logic functions correctly. Also again, you click on Add Source. You click on Add or Create Simulation Source. Next, Create File. I name my create file is Simulation. Okay. Finish. You skip it and click OK. Yes. You click on source. You click on simulation source, and this is location. You click on simulation, and in this window, you programmable for check logic and check test pan. The first, you see time scale 1 nanosecond and 1 picoseconds, which sets our simulation time unit to 1 nanosecond with a precision of 1 picosecond. And this is my module's simulation. And inside the bracket, we declare rect A in and B in. B in is about inputs. Y is output. I name is N out or out and not out. Logic gate. You're going to check function logic for schematic. You choose the file. You choose your file, logic gate, copy it, and paste in a simulation file. UUT is under unit test. A in output you see A. B is B in. Initial, begin, if A equal 0, A in equal 0 and B in equal 0. After 5 nanosecond, switch to A in is 1, A in is 0 and B in is is 1. After 5 nanoseconds, A in is 1 and B in is 0. After NZN 5 nanoseconds, A in is 1 and B in is 1. You finish dollar and finish and modules, and my code is correctly, and I check the simulation. You click on run simulation and run behavioral simulations. You save, or you click on Ctrl S. Now this is a window for simulation. Now everything is set. You zoom fish. Let's run. When I run simulation, you can see A in, B in, N out, or N not. In when both inputs is 0 and A in 0 and B in 0, N out and get and always is down, but not is high. After 5 nanoseconds, A in is 0, plus B in is 1, 0 and 1 in out is 0 or is 1, not A. You see, not I assign for A is 0 and not A is 1 is correctly. Similarly with A in and B in 1 and 0 and A and B plus 1. So our design is very fast.